In this video, we are going to create our order service, and we are going to do the common order service setup just like the way we did for catalog service. And then we are going to understand how RabbitMQ works and what are the kind of messaging pattern it supports. And we are going to configure our Spring Boot application with RabbitMQ integration. I have created a card for setting up order service. So here again, similar to catalog service, I have listed down what are all the subtasks we need to do for setting up a walking skeleton of our order service. So while building this order service in the last few videos, we have extensively talked about various things like how to structure our code into various packages and how to add Spring Doc Open API, Rest Assured and Git Commit ID plugins, Spotless plugin for code formatting, and how to set up GitHub Actions for building and creating a Docker image and pushing it to Docker Hub, and how to set up Flyway migrations for setting up the database tables and all. And finally, how we can configure our Spring Boot Maven plugin to create the Docker image with a custom name. So all these things we have extensively discussed and then implemented for catalog service. So I'm not going to again repeat all of that. So what I have done, I have created order service with the starters that we need for our order service, and then I have set up the common things which we have discussed here in our repository also. So let us take a quick look at what we are going to select here. So we are going to build RESTful API and dev tools and configuration processor for local development, and we are going to use Spring Data API with Flyway and PostgreSQL. And a new thing is we are going to use RabbitMQ, where we are going to publish the order related events to RabbitMQ, and notification service is going to consume them. And we will use some validations, Actuator, Prometheus for monitoring, test containers for testing and local development, and resilience for J is for applying resilience patterns while communicating with the catalog service. So these are all the starters we need to add, and then I have generated the application and copied the code into our repository. So in the root pom.xml, I have added this module order service, and then within the order service, so I have added all these customizations for our Spring Boot Maven plugin. I have added the custom builder for ARM based image generation and gave the custom image name, and added Git Commit ID plugin and Spotless Maven plugin for code formatting. So this we have already discussed all these things earlier. And also we have added Spring Doc Open API and Rest Assured for testing. So nothing new here. And in addition to that, if you take a look at our application here, again there is nothing much yet that is order service related. So I have created an exception class called order not found. So we are going to need this in the upcoming API implementations. And again I have global exception handler. Again, this is very similar to how we have implemented for catalog service. And regarding the configuration, so this is, we are all familiar with it. And one thing to remember is by default we are using port 25432. For catalog service we used 15432, so that is a different database. And RabbitMQ configuration, we are going to configure our RabbitMQ in the Docker Compose, and we are configuring this default values. So this is one. And next we have created Flyway migration scripts. Here in our service we have simple two tables. One is orders and another one is order items. So in the orders table we have default primary key and a generated order ID number and username who placed the order. So as of now we don't have any security in place so that we don't know who is the logged in user who is placing it. So for now we are going to statically use some name, but while integrating with the OAuth security we are going to use the actual logged in username. And then we are going to capture who is the customer this order is placed for, and what is the delivery address and the status. So all these things, again order items, for one order there could be multiple items, so we are going to capture all of that here. So this is a simple order related tables we have here. And under SRC test Java, again this is very familiar. When we generate with the test containers, it is going to generate this, and then we refactored the configuration to containers config. So here is one new thing in the sense, earlier we have seen a Postgres container definition. In addition to that, because we have selected RabbitMQ in our starters, it is going to add this RabbitMQ container definition as well. And by default, it is going to, it came up with latest, but I have used some actual version here instead of giving the latest. And again, we are familiar with this base abstract integration test class. And then this is the default test that is generated. So this is the common setup that we have done. In addition to that, I have created another order service YAML file under GitHub workflows. So again, it is very similar. We are going to check if there are any changes under order service only, then this pipeline is going to be triggered, and we are going to build this and then log in into Docker Hub and then push into Docker Hub this custom image name. So this is workflow setup. And the next important thing is in infra, earlier we have configured catalog DB. Now we are going to use a different database instance, not the same database instance. We are going to use another orders DB. Again, we are going to use same Postgres 16, and we are giving the container name orders DB here, and same configuration. So this is bookstore RabbitMQ. Here we are using RabbitMQ, and this is the custom container name we are giving, and we are specifying if these are the defaults, but if you want to change any value for username and password, you can change it. So these are the values. This is the AMQP port, and this is the web UI port. So once we start this, we can go to this port, and then we can see web UI for RabbitMQ. And here is the health check. So this is the common setup we have that is ready to start with order service actual feature development. As discussed earlier, we are going to use RabbitMQ as our messaging system to communicate between order service and notification service. So the use case here is when a customer placed an order, we are going to send a notification email to the customer saying that your order is successfully placed. Or when the order is successfully delivered, we are going to send an email saying that your order delivered successfully. Or if it is cancelled for any reason, we also send an email notification saying that your order is cancelled for so and so reason. So then why to use messaging system, any messaging system at all? Why not create an API endpoint in notification service and call from order service? Why should we use a messaging system? So the reason is when we are designing our application using microservices architecture, we need to think about failures and be able to gracefully handle those failure scenarios. For example, what happens if the notification service is down? When a customer placed an order and our order service is up and running, we received the order, we persist the order details into our database, and then we need to send a notification and assume notification service is down. So how do we handle that? So we need to think about, can we handle some of the use cases in a asynchronous fashion? Not everything needs to be in a synchronous communication. So here, just imagine we received the order, we persisted the order into our local database, Postgres, whatever, and then later we process them in an asynchronous fashion. So first we send a message to one of the messaging system, and then notification service can consume that and process it accordingly. So in this way, there is no need for notification service up and running. Even if it is down for some time, whatever reason, still order service can continue to take the orders, and then they simply put the message to RabbitMQ and they can forget about it. So at that time, if the notification service is already up and running, well, it is able to receive the message and then process it immediately. But if it is down, maybe after 10 minutes or even 1 hour, if it is back up, then it can continue to consume those messages and then process it. So this way, this processing is loosely coupled, and even though both systems are not up and running at the same time, the application still continue to function. So that is the benefit of using asynchronous communication with messaging systems. So that is why we are going to use RabbitMQ as our messaging system, and then implement sending the notification emails using this asynchronous communication way, instead of making an API and then calling it from order service. Then the next question could be, then why RabbitMQ? Why not Kafka? Why not some other thing? As I discussed in the previous microservices introduction video, in this particular application context, RabbitMQ provides sufficient capabilities to handle the scenarios. But if we have a different scenario, maybe we can go for other more feature-rich platforms like Kafka. So let us understand how RabbitMQ works, because RabbitMQ is slightly different in its behavior than other messaging systems like Kafka. So if you are coming from a background where you have used Kafka, it is slightly different. So it is important to understand how RabbitMQ works differently. So here, if you have used JMS like old messaging systems, ActiveMQ, like they are also a little bit different, where a producer sends a message to a queue, and there can be consumers to that queue which directly receives the message. Similarly, there can be topic. If you want to publish and have multiple subscribers, there can be topics where a producer publish a message to the topic, and there can be a number of consumers, and each of them receive a copy. So that is how those traditional messaging systems work. But here with RabbitMQ, there will be an exchange, and as a producer, once you send a message to this exchange, you send it with a routing key. So based on the routing key, it is going to forward that message to one or more queues, and each queue can have one or more consumers, but at any point of time, only one consumer will receive a message. So what is this Rabbit routing key? What is this bind key? So let us understand that. So think of it like a post office, where if you want to send a mail, you don't directly send it to the person, right? You send it to the post office by writing an address to it, and then they deliver it to the home, right? So in the similar way, you always send the message to the exchange and specify the routing key. And there are different types of exchanges, and there is a mechanism where you bind each queue to this exchange with a specific type of routing key process. And then based on that, exchange will forward that message to one or more queues, and consumers will consume it. So let us understand what are the exchange types. So first, there is a direct exchange. So it is the simplest among all the other type of exchanges, where you simply specify some key equals to routing key equals to some value, and it is as simple as that. And whenever a producer send while binding this queue with the exchange type, you specify all the messages with a particular routing key equals to this value should be sent to this queues. So if you have a direct exchange, you can configure like this is orders queue, where any message with routing key equals to orders, forward them to this queue. And probably this is order accounts related queue, and any message that comes with routing key equals to accounts, forward them to this queue. So like that, it is a very simple process, and there is no wildcards or anything like that. You just specify routing key equals to some predefined straightforward string, no wildcards, nothing, no pattern matching, nothing. So that is the direct exchange. And there is a second type like topic exchange. Topic exchange provides the capability of where you can specify the binding pattern with a wildcard patterns. What does that mean? So when a producer sends a message to this queue, and these queues will be bind with the exchange supporting a range of wildcard patterns and like this. So here you can specify orders.new.star. This is the binding key for this queue. So any message that comes with a routing key that fits with this pattern, orders.new. Let's say Hyderabad, orders.new. Bangalore. Let's say they are suffixing with the city name based on the delivery address. So all these messages can go to this queue. Like that you can configure. It is not an exact match like a direct exchange. It can be a pattern with wildcards. So like that you can configure. So based on that, whenever a producer sends a message, it compares that with the patterns of these bindings and automatically forwards that. So which means, let's say you send you can configure multiple queues, and if the message that received by exchange is matching with multiple queues, a copy of that message will be forwarded to each of those queues. So all the consumers will receive a copy of that message. And finally, the fan out exchange is, it doesn't care about binding key. Like whenever, if it is a fan out exchange, every message it received, it will automatically forward to all the queues that are bind to this exchange. It doesn't check what is the binding key or routing key. It just forwards every message to all of the queues that are bind to this exchange. So it is like a simple broadcasting message. And one more thing is, usually if there is only one consumer, it will always receive that message. But if there are multiple consumers for a queue, only one consumer will receive a message at any point of time. That means they simply follow round robin algorithm and then keep receiving messages by different consumers from the same queue, and they won't receive the same messages by both consumer 3 and 4 at all. So only one of the consumer 3 or 4 receive the messages from this particular queue. So there are other types of exchanges as well, but most of the commonly used are these 3 types. And in our case, direct exchange itself is sufficient for our scenario, where our need is, whenever an order is placed, we send a message with a key that orders new orders, and orders delivered, orders cancelled. So it is a very simple process, and in our case we can simply use direct exchange, or if there is a need for more consumers, then maybe we can go for top exchange also, but in our case direct exchange is sufficient. So we are going to follow this direct exchange pattern, and we are going to implement our use case. So first I am making our configuration, RabbitMQ configuration properties in application.properties file. So here we are having a common prefix orders, and then we are defining the exchange name, orders exchange, and then we are defining queue names for 4 different queues: new orders queue, delivered orders queue, cancelled orders queue, error orders queue. So these are the queue names here. So after defining this, we are binding this to the application properties record with the prefix of orders. So all these values are going to be populated into these values here. So now we have created a RabbitMQ configuration file, Spring Boot configuration class. So here we are taking these application properties, injected into it, and then, so this is the first bean we are creating with direct exchange. So here we are taking the order exchange name and then creating the direct exchange. So this is the first thing. So next one is, we need to define a queue. So here we are creating a durable queue, and we are taking the new orders queue. So here this is the new orders queue name. So it is taking the queue name and then defining a queue as a bean. Next we need to bind our queue with the exchange, and so here we are binding it like this. We are binding the new orders queue to the exchange, to our direct exchange, with new orders queue name only. So here it need not be exactly the queue name itself. So here you can even put orders new or new orders key. So anything you want, you can have another configuration property to define the routing key, but simply I am using the same order queue name itself as the routing key. But if you prefer to use a different routing key, you can configure. So it is as simple as that. So with these three, what we are doing, first we are defining a exchange, and then we are defining a queue, and then we are binding that queue to the exchange with a routing key here. So the routing key name happens to be the same as queue name, but it can be different. So once we have a configuration like this, we can do similar thing for other queues as well. So again, we are defining another queue as a being delivered queues, and then we are taking the deliver order queue name, and again configuring a binding to the deliver queue with exchange with the same delivered queue as a queue routing key. Same for cancelled orders binding here. So next error orders, and then binding. And finally, we are going to use a RabbitMQ template for sending the messages and all. And what we are doing is, when we send a message, we are going to send a bean, and then we are configuring Jackson to JSON message converter such that it will automatically convert the message into JSON structure and then send it to the message queues. So it is going to perform automatically with this configuration. So with this configuration in place, and earlier we have already seen configuring our RabbitMQ in our infra file, Docker Compose infra file, and I have already started our components. So we have catalog DB, orders DB, and RabbitMQ started. And as I already mentioned, we can even access the GUI of RabbitMQ on this 15672. So let us check that. So here I am accessing localhost 15672, and I can use guest as credentials, and I can log in. So right now, if you go to exchanges, so these are the default exchange automatically created when you start the RabbitMQ. Now I am starting the order service application here, and once the application is successfully started, it should create the orders exchange and then create all these queues that we defined in our RabbitMQ configuration file. So here we can see it is connected to RabbitMQ here. Now let us go ahead and check. In here we can see orders exchange is created. Now if you go into orders exchange, we can see cancelled orders is bound with this routing key cancelled -orders. Similarly, there is delivered orders, error orders, new orders. So all of them are bound to these respective routing keys. So now we have configured, and these queues are configured. Okay, now let us verify whether we can successfully send messages and receive messages by writing some sample code using Spring Boot RabbitMQ integration. So for demonstration purposes, I have created a controller. Here is my controller here. So what we are doing, we have a RabbitMQ demo controller. We injected Rabbit template and application properties, and then I have a API endpoint /send, which takes a my message record as a payload, which contains routing key and my payload. Payload contains simple content property. So here I can use Rabbit template convert and send method. So the first argument is the exchange name, and we have that name configured as part of our properties. So we are calling order event exchange. And then the next one is we need to send routing key. We are taking this routing key value from the payload itself, so that we can test sending a message to orders new queue, order delivered queue, like that. And finally we are taking the payload here. So this is the sending part, and we can also write a listener very simply using annotation approach. So here we have two listeners. One is pointing to this new orders queue. So this is the configuration property we have in our properties file. So this is the property name. So that represents the queue name here. So we are specifying that queue name here, and we are handling the payload. and similarly we have another listener for delivered queues, delivered orders. So this is how we have two listeners. So now let us verify by sending a message to this API endpoint and verify that. So here I am going to my Postman, and here I am sending localhost 8082/send, and the JSON payload is routing key new orders. So this is nothing but same as our queue name. So if you go to here, so we have used the same queue name as the routing key, if you remember. So we are using this new orders as the routing key, and I am sending the payload content order created with ID 1234. So now I sent the API request, and now if I check in the logs, I can see I received a new order created with ID that is coming from our listener. So similarly, if I send a message to this delivered key orders, order delivered with ID 123, so now it should route to with this routing key, it should route to this delivered orders queue, and our listener should receive it. So now if we go to so here you can see delivered order delivered with this. So that message is coming from this listener. So we can confirm that our configuration is working fine, and we are able to send a message and receive a message. So but anyway, we are not going to receive any messages from this application here in the order service. We are going to receive like this from notification service. But we can confirm that our application configuration with RabbitMQ is fine, and we are able to send and receive the messages as well. So in the next video, we are going to start building our API endpoints for taking the order.